Hello again. We have group number 12 now on the line. They will be presenting an innovative set of crutches for an application. Group 12, you guys ready to go?
Sir,
kind of. Okay. They're going to show the last 2 semesters of work and how they can help. Ready? Whenever you guys are ready.
All right, so good morning, ladies and gentlemen. Before we begin, I'd like to thank you guys for being in attendance for a presentation today. My name is Arsene Shimwe. This is Andreas Hamdad, Suri Mokopadie, Rachel Kenny, Jose Gazaz. We are G12, and today we'll be giving a presentation on a senior design project, which is the retracting crutch for elevator surfaces, also known as the retract.
This here is the crutch that we know and hold today. Pretty simple design. This is the crutch that we designed, also pretty lightweight. This right here is the retracting mechanism that we designed and the cable to enable it. The medical industry today is to provide, or provides effective treatment for the sick and injured. Doctors recommend crutches for any ankle sprains, lower extremity injuries, or even people suffering from stroke. The 2 main functions of a crutch is to reduce the load on the injured leg and to provide balance and stability to the person. The one thing that it does not do is take into account elevated surfaces.
So a quick background when we chose this project. Crutches have been around and cited since ancient Egyptian times in drawings helping people to walk. But the biggest impact was during the Civil War when doctors instructed carpenters to design wood sticks to have the wounded and the amputees to get off the battlefield. But the first crutch actually didn't get patented until 1117 by Emily Schlick. And the actual first crutch design, the first adjustable crutch design and patent was in 1948. And as you see, 70 years later, the crutch still the #1 sold crutch in the world. Some of the statistics we found, the CDC conducted research in 2014, provided details that 6.8 million Americans uses assistive devices a year. Out of that, 35% uses crutches, and sadly, 20% of them, around 500,000 Americans, get re-injured while going up and down the stairs or elevated surfaces. Also, the San Francisco research conducted research in 2016, and it's 10 million crutches sold annually in the United States with a $350 million market, and they're expecting a 10% increase for the next 10 years.
This here, my partner is demonstrating using the crutch, the normal crutch, using both crutches on one side. It's relatively easy going up the stairs, but when going down the stairs, it's a little bit more difficult. He has to use both crutches on one side in order to hang on the handrail while going down the staircase to help him stay stable. And when he's going down the stairs, he also has to take the crutch from one platform and then to the next, so it's a little harder. Finally, as you go down the stairs, it's harder to keep in balance, and it's just not safe.
Did you really fall?
Yeah, you had to use that. Okay, so with this information in mind, our main objective was to basically design a crutch that could 350-pound load, have the mechanical capabilities to retract 4 inches, thus safely allowing the user to elevate, ascend and descend down elevated surfaces.
We had to comply with a couple of different standards and regulations, like the healthcare codes and practices for medical equipment, the OSHA standard regulations for the height of each platform and the length, as well as the ASTM material codes to comply with the loading of the crutch. Our design is meant for a maximum use of 350 pounds, but it can be adjusted for other heights, weights, and ages.
So our previous design concepts that we had going through was a gas compression spring, and the way it would work is it had a space where you can release the pressure in the canister, and that would allow you to adjust heights. So we ended up going against this because it caused a little bit of issues whenever the patient had to go up or down the stairs. They had a possibility of force back. So we ended up moving away from this concept and moved on to the push button mechanism. It's the same mechanism that's used in y'all's ballpoint pins that y'all using right now. And the way it would go is that once you apply pressure onto it, the ball inside of the baffle of our central strut would move to its next position, and it would basically just adjust to 2 different heights. The issue we had with this was that we had to design something that would go up and down a minimum of 4 inches within something that's about half or about an inch. So it just caused too many issues, so we moved on to our final design concept, which is the one you see right now in the black crutches, which is the spring compression mechanism. And the way it works is that you have a button that is attached to the handles, and what it does is it activates the mechanism, allowing the spring to compress down 4 inches, and once you repress it again, it'll allow it to re-expand again back to its original height.
All right, so our final design for our prototype focused on 4 main components, which was the user input, the locking mechanism, the height adjustment, and also the supports. A lever is placed at the handle within easy reach of the thumb for operation. Once it's pressed, a cable and tension pulls the stop pin out of the lower rod, and that allows it to be released. Putting weight on the crutches allows the spring to compress and the user to move it to the position desired. Releasing the spring allows the pin to be locked in and it to be stable.
So these right here that you see are going to be just 3 out of the 34 drawings that we have to offer. The first one, as you can see, is going to be the drawing of the full assembly with the attachments that were custom made along with our compression canister. The next drawing is of the compression canister in an exploded view, so you can see all of its components. And finally, you'll see the attachment that was customly designed that will allow the canister to be held in place along with the side struts. That way there's no movement in those, it's just stable.
Okay, since our crutch is loaded and unloaded by the weight of the user, it's a dynamically loaded structure with repeating stresses and fluctuating stresses. So we had to account for the stresses, the fatigue, and also the material selection was our most important factors. For the stresses, the shear stresses in the pins and the fasteners was determined, and also the bearing stresses of the supports. That way they didn't exceed the allowable stresses. And as well as the, for the inner tube and the rod, column buckling had to be determined so to prevent against any buckling or yielding. And we used Euler's methods and also Johnson's methods. So the applied loads didn't buckle or yield and buckle any of the rods. Analyzing fatigue was more important because this type of failure is sudden, and for a user on a crutch, it's drastic as they already have an injury, and it could be devastating. So the factors involved, we had to account for stress concentrations in the notches and the holes, as well as the different types of loading stresses, and also the life cycle that we're going to be using the crutch for. The modified Goodman's criterion was used, and the factor of safety guarding against fatigue was calculated, and a static check was done using Langer's criterion to check against any first cycle yielding. So for material selection, we had to account for the stress versus weight and also the stiffness versus weight because we needed a lightweight crutch, but also to be rigid and sturdy enough to handle the loadings repeatedly. When choosing our alloys, manufacturability was looked at because the way that the materials are processed for our parts, any kinds of surface conditions like scratching or roughness could reduce our fatigue strength, as well as corrosion resistance we looked at, because any type of corroding on the outside would reduce the integrity of our parts and also reduce the fatigue strength.
For the final FEA analysis, we decided to conduct FEA on the original Crutch and on the modified Crutch to compare the results and also all the parts, all the drawings that we designed. Some of the requirements we had to be able to, the crusher had to be able to maximum load of around 1,500 newtons. Vertical with a few constraints, and we wanted to do even though the crutches, none of the crutches got standards how much weight you have to apply on them. We wanted to do a safety factor of 2 to make sure we cover the height and weight regulations. And because it behaves as a mechanism, you never have a static load. You got different loads that are being applied at different angles. We went ahead and conducted FEA analysis while calculating the angle. When you like go over 56 degree or 36 degree angle. This is some of the drawings, mesh analysis. We did long constraint, compressed, fully retracted, we got like over 40 some FEA analysis. For the upper part of the, for design, we decided to stay with aluminum 6061 T6 because it was cost efficient, lightweight, corrosion resistant, easy available. For the handles, nylon 6-6 because it's a little bit, the tensile strength is harder than the regular nylon. For our lower mechanism, we decided to go with aluminum 6066 T-6 because it got higher strength and more impact resistant than the regular aluminum, and also corrosion resistant. For the bolts, spring, and all the steel fasteners, we decided to go with ASTM 8449, pretty much grade 5 steel, because the higher strength, because most of the bolts, the locking pin going to receive most of the stresses of the design. For the supports, we went ahead and we got it 3D printed with PETG filament instead of PLA because it got a higher tensile strength. It was a quick turnaround, like 3 weeks. For regular, if we wanted to get them in aluminum, it was like 3 weeks, and we got them printed like in 2 days turnaround, so it was pretty quick. This is some of the FEA analysis drawings. We got like a manual in the back with all of them and more details about them.
Well, so after completing a full cost analysis of design retail cost, totaling $120, which is pretty affordable compared to other products out there in the market. And although some products have the same ergonomic features as ours does, none of them have mechanical capabilities to get users safely up and down elevated surfaces, which really puts us at a competitive advantage.
For the economic analysis, economic feasibility, the team decided to do economic feasibility to make sure our design was profitable, it was a good investment, and it's worth to design it. And we mainly use the time value of money method because you can calculate the net value, the net present value, your future worth going to cost. And some of the good practices, if your net present value is higher than 0, it's a good project to accept. So our net present value became 100K. And then we did research around for businesses and investors, and they say the interest rate for our initial investment would be between 10 to 20%. So we went ahead and averaged a 12% interest, and then we calculated the IRR, the internal rate of return. They came up to 24%. This tells us that's the highest interest percent we can take and able to not lose money or not make money. So good practice, if the IRR is higher, the rate of return, that's a good investment since OR is 24 and the rate of return is 12%, so we got a good amount. The payback period, it would take us like, we calculated 3.5 years to pay the initial investment. Then we decided to calculate the break-even ratio because this was letting know how much of our revenue we're going to use to pay back the initial investment. So on our revenue, there's almost $450,000. We're going to use 56% of that amount to pay the initial investment. And the finally the rate of investment we calculated, because this led for investors, banks, they want a higher interest percentage, 20%, and able to be feasible and more like appealing to them to invest on the investment. So ours was 31%, and finally we got a profit of 5 years of 135,000 and a revenue of 432,000.
So the way that you would activate this crutch and make it work is by going up the stairs, is you would activate the mechanism, compress it down to its lowest height, put the crutches on the next step, and put your foot, and do this sequence until you get all the way up the stairs. For going down the stairs, you're going to reactivate the mechanism again. You're going to put your foot on the first step, followed by the crutches, and continue the sequence until you get all the way down the stairs.
For our future considerations, since we personally funded the project, we had some limitations in terms of manufacturing certain materials, certain shapes, and features that we wanted to add on there. One of the features was we wanted it to be height adjusting for different users. Right now, it's set specific for one user. We can adjust it, but it's a little bit of a process. But if we could have an easy adjustment height, we can accommodate more people just with one crutch. And also a more streamlined design, just for the supports in general, more aesthetically pleasing, as well as for the cables. Right now the cables are, you can see where they're at right now, but we like to hide them inside the crutch.
All right, so that just about wraps up our presentation. You guys saw how we developed it, manufactured, tested it, and validated it. And once again, I thank you guys for being here for the presentation. And, we're open to any questions you guys may have for us.
Yeah, so first and foremost, the material selection process on that was really good.
Yeah.
That was really sharp. I
agree.
like that. I think that was, in my opinion, one of the best material selections. Very important when you're doing design work. So you guys did your investigation on it. You asked your whys. Corrosion, that's a big thing here in the oil industry. So excellent job on the material selection, and the way that you guys did your FEA, that was really good. So I have a couple questions. So first one is, you know, your spring selection. So did you guys do a calculation for like the time it takes for this thing to react? And where I'm going with this is, like, you know, I'm roughly the same height as, you know, Dr. Garcia, but obviously we're probably like 100 pounds apart. So, you know, how would you accommodate for something like that? I didn't see anything, you know, that would accommodate for something like that. So when I go put my 260 pounds of muscle on those crutches, it's going to react differently. So what would you guys, how would you accommodate for that?
Well, what we did using the mechanical materials book, we went through the whole design, the spring, so we kind of backwards engineer. So we first calculated the spring constant, and then we did the deflection, how much it would cost, like it would be to deflect. We needed 4 inches to deflect, so being able to safely clear the steps. They range from 4 to 5.5 inches for OSHA standards, regular stairs. So we did all the calculations, and then we applied. We end up like doing like simulations of like different heights and different weights. So like applying 250 pounds, like how much force it would take to push the spring down, and then we end up doing like a chart. It's all in the calculation part. We went with the more average sprint. They can take all of them, like an average, like if you 200 pounds, if you 250. For our future considerations, we were thinking about adding a softer spring, because right now, like you say, like for you, it might be easier to push it down and lock it in place, for some people having troubles.
Okay. So when this thing is in a flat state, is the spring intended to be fully flat?
No, because fully flat is the final length, that's cause of more buckling, and the cycle of the spring will like go from 5 years to 3 years, because you don't want to collapse your spring all the way to 75%.
Okay.
So we did it to like 60%, and we will have like an inch that is free length.
Okay, so would it be fair to say that maybe some of these probably have like weight restrictions?
Yes, sir.
Versus height? Okay,
Yes, sir.
okay. I'll let others ask some questions before I get into
Yeah, I have a few questions.
Yes.
How many of you have used crutches for real? Because you need it. For how long?
About a week.
A week. And you?
I had knee surgery, so 4 months.
Okay, so my question is, I have also used crutches. I never went downstairs like that. And I mean, going downstairs when you have crutches is scary.
Yeah.
Because of the balance thing and everything. So basically, you don't leave the crutch in the step that is higher, and then you bring your body. You're most likely will put the crutches first in the bottom step, and then bring your body. So thinking about that.
It's a weapon too.
From that part, then it's good. So, from that part, it's like, okay, what I'm thinking is like, if there has been injuries while using crutches, is also because there is a period when you have to train your brain to use the crutches. Because it's very difficult that your brain is used to go downstairs, upstairs in a way, and then you have to add the crutch. So I'm just having a little bit of trouble seeing actually how somebody who's going to use the crutch for 1 week, for 2 months, for 3 months, is going to make the investment to buy these kind of things when they also have to train the brain and like, I mean, when you're working with crutches also, you put the pressure like in the middle bar, not in the armpit.
Mm-hmm.
So then you are walking and you also have to put your strength there and you have to actually activate the system. That's the thing, the kind of thing that I'm thinking about this.
Well, anything you purchase, you always have to learn how to use it. And just like you said,
yeah, but you don't practice with crutches before having the injury.
no, you don't.
So you
But
have to learn.
just like a regular crutch, for the first time users, I had no idea as well how to use it, right? So I had to train myself, read instruction manuals, or get someone to train me how to use it, right? So ours does come with instruction manuals and a user's manual. And it's fairly easy, to be honest, on how to use them. There's different type of movements. You can go upstairs and downstairs, and there's different type of movements we have for if you have both legs injured or one leg injured. And so yeah, again, it's just a learning process as well.
Yeah.
The
You're
thing also is we had a blooper reel that we were going to show, but due to time constraints we didn't. But it shows all the different ways that we were trying to go downstairs. So this was one method. We tried the method of putting the crutches first and then stepping down. The issue with that was that once we stepped down on it, it brought your shoulders up. It was very uncomfortable. There you go.
So if you're going with the two crutches, I mean,
Another thing, it depends on what your type of injury is.
of course. But I mean, there are different ways. The thing is, like, you get used to, and if you have to go up and down too many stairs, you use the elevator.
Yeah,
So yeah, so if you're using it at a house, I mean, unless you're,
Yeah, no one has elevators in their
unless you're an
houses.
NBA player, you don't have an elevator in your own house. So this is more for situations where you
Yeah,
don't have access to that.
and the biggest, we actually went to the Memorial Hermann Sports Medicine and talked to Dr. Agassi. The biggest deal is that like we said at the beginning, is 70 years later, yeah, you got more ergonomic crutches, single leg and stuff, but nobody is actually addressing the biggest issue. That is like 500,000 people get injured a year going up and down the stairs because up here, yes, it's elevators, but they're broken half of the time. The parking lot always elevators, and then you got a 2-story house, you have to go up the stairs. And then parks, they don't got ADA accessible. Like pretty much we find a lot of facilities, they got all over 30 years, they don't got ADA stands set up yet, and then you have to go up and down the stairs. There's no way around. What we found also is not a set standard how to go up and down the stairs. The doctor just tells you use them. It's a YouTube video and good luck kind of thing.
Yeah, I know.
Yeah.
But how much is one of the regular crutches compared to one of these? One of these at 120?
These are ones.
Yes.
Now, this 120 also comes with us getting all the materials here in the U.S.
So then,
Yeah.
We did do a analysis and checked. If we were to outsource this out to India, per se, the materials itself would cost 60% less, and the workforce to be able to actually put this together would be 40% less as well. So we would reduce the cost of the crutch going from 120 down to about almost $60.
Which
And
is more
standard
competitive with that.
Yeah.
Yeah, these are
and our standard set of crutches run at about $40.
Mhm.
So to have
And-
something that's more convenient going up and down the stairs for $20 more, and it has something to do with safety, especially going back to the point that 500,000 people are injured yearly using crutches. You have an injury and you get re-injured again using something that's supposed to help you. It doesn't make sense. So we've made the analysis that people will, in the end, choose to invest $20 extra to have something that's going to be much safer and reliable.
Yeah. In your time value money analysis,
Yes.
You did that from the investor point of view. And with how many units is that? I mean, three
That's
point-
so with the economic feasibility, we did an initial investment of $350,000 that will cover 6,500 units. Also the taxes, the advertisement, and everything to run it for 5 years.
Because it would be interesting to see this from the injured point of view. So I'm going to buy this crutch, and how many is my? And how many?
Yeah,
years
that's
is
why
it?
we put this slide here. Some of this, like the dual ergonomic crutch for 220,000, they sell 20,000 a year. The ultra crutch Mobi LCC for 149. Amazon outsources places they sell 7,000 a year. And then the other two, they're for 500, 600. They're just prototypes out there. They're not even they're not even in the market yet. But that's what they were trying to sell them for. We didn't want to be in that price range. But in the PDD manual, we did a competitors analysis, and we got over 10 different crutches that the average is selling just in Amazon and other places is selling at least from 5,000, and the number one crutch is selling like 20,000 units a year. That's not including with hospitals and stuff that get contracted.
But in this chart, not only putting the price of the crutches, it would be very nice to have like the number of units sold.
Okay.
Like
Okay.
just to have idea of the market share and everything.
Absolutely.
Thanks.
Okay, let's see, actually I'm a bit concerned about the, what happens if you load it, pull the trigger when it's not pressed against the ground? Say it's compressed and then you pull the trigger. Can you show that?
So
Yeah.
yeah, it'll pop back up.
Well,
So
can you
part of the
compress it?
Yeah, put it all the way down.
And then, what happens if I'm barefoot, I'm sitting at home, and I accidentally release that on my foot?
Well, we wouldn't imagine somebody having it on their foot, but
But
yes, that is something that we can look on for future considerations. It's something that we didn't want it to be able to push back immediately, so it's something that we can definitely look upon.
Yeah, for future reference, we're gonna put a more softer tip on it. Just-
And also like an end stopping mechanism so that it does
Use
not
as self-defense.
go past.
Okay, so if you walk in the parking lot at night, you've got something.
If you change a type of spring, maybe you
Right.
can
Right.
change
Like a softer
the
spring.
Yeah, that's what
reaction
when
of
we
the
when we figured out the spring, how powerful it is, we decided to stick with it. But that's what we put on the future consideration: a better spring, softer, because some of the people when we tried the crutches with some of the lighter personnel, like 150 to 180, they were having kind of issue to get it all the way to the 4 inches to
So
retract.
what are the different kinds of crutches that are right now available? There is nothing like this.
Nothing like this. They got more ergonomics. Go
No, it's
ahead.
okay.
No, go ahead.
Oh, okay. So for crutches like this, the only type that have the same functional of going upstairs for that function are the two that are on top, but those are both conceptual. The difference between ours, we wanted to make ours more economical and affordable for people to actually want to buy it. Because I think the S-Crutch is made of carbon fiber, and it's a completely different design. So it's going to be more expensive regardless. And the hydraulic lifting one is also bigger and heavier, and also more expensive as well.
So, extending to what her question was, when you talked to the doctor, did you discuss while coming down the stairs, it would be a different kind of movement that a patient has to go through, and will they recommend that kind of descending down the stairs?
They usually recommend sitting down and going down the stairs that way, is what they usually
like
recommend.
Sit down completely and then
Yes, sit
go
down completely and go down the stairs.
So
if
there's
you
no use
if you
of the
feel
crutches.
unsafe, going down the other way. And most
That's
people
in-
do feel unsafe
So
going
that
down.
they might only imply or employ at their house, you
Mhm.
know, what in the public,
You're not going to see
you know,
them in
public
public
situations.
stairs.
They
That's
might
what they
not-
recommend
might
though.
not be
That's why
comfortable
it's
sitting
that's
down.
why even though ours might be, you know, even though you can use these, another thing is just feeling safer. Most people don't feel safe because their center of gravity is thrown off when they're coming up that way. But with ours being lower, you know, you feel safer that you can actually go down and you can be more comfortable with it with, you know, use, more and more use.
So do you consider instead of having a single point of contact, you might have 3 point of contact? That
We
way
thought
you
about
can
that.
extend the center of gravity.
We thought about that, but I think we wanted to stick with one just so it's not, you have to worry about the step length. And I think it's 7 inches. So you have to make sure it's, they do have some crutches that, like crutch tips that you can add on that actually make it a little bit bigger for people that feel unsafe in that way.
On your mechanical design, your stress design, what was the factor of safety you used on your loadings?
On the, we used 2 for
Okay.
most of them, but when we calculating the fatigue ones, they were a little higher, which we wanted them that way because obviously it's the repeated ones.
And did you do any kind of, not fatigue, but just regular strength, did you do any kind of dynamic analysis, or did you just do static?
No, we did dynamic. We did
Okay.
dynamic first
Okay.
because that was under the assumption that it would fail that way first, and then we did a static check.
So you took your dynamic, like weight of a 300-pound person, maybe dropping it to short distance,
Right.
and then there's a factor of safety applied on top of that?
Mhm.
Right.
Okay, good.
And with different angles as well.
We applied it with I believe it was like a 30-degree range, 15 on each side.
So why would you use modified Goodman or Wingers versus a Von Mises?
I used the Shigley's mechanical design book,
Okay.
and that one wasn't actually in there.
All right.
But out of the ones that were in there, the modified Goodman one was the one that it's used mostly, it's understood mostly, and although it's not as conservative as the Soderbergh one, which is the one we used originally,
Mhm.
like we could have used that one, but we wanted it to be economical. And the Soderbergh is safe, but sometimes it's over safe. So it would make our less economical than the Goodman that is just, you know, safe and
Okay. Who did you take for mechanical design systems? Oh, okay. I don't know if it's Hurtado or not, 'cause I took Hurtado.
I took Hurtado too for
Okay.
mechanics and materials.
So,
Yeah.
Something to say.
no, so what's the objective of the modified Goodman?
I know.
What is the objective of the modified Goodman?
Well,
I'm not trying, this isn't a final example. Well, maybe for
the modified Goodman takes into account the alternating and the mid-range stretches. It was
Okay,
the stresses from repeated stressing.
okay,
They basically, you want them to be underneath the ultimate tensile stress,
okay.
which is like complete fracture.
Yeah, okay, so the Von Mises kind of gears towards that. It tells you absolutely everything you need to know right instantly, right? So.
Well, for the von Mises, for fatigue stresses, you'd have to, I think it's better to use the principal stresses when doing fatigue, unless I think you could transform the von Mises stress as well, but it's more, not traditional. It's more, the principal stresses are used usually, I guess, usually. Because I don't know what the word is.
Okay, then,
So,
Yes.
So, now my question might be a little off the scope of your project, but have you checked if this might get covered under medical insurance? So that the cost can come down for the patient?
Yeah, the way it works, when we did the research and talked to the doctors at Memorial Hermann, we did, that's what we kind of, when we, or lower to make kind of profit with 5,000 units or 65 units in the next 5 years. But we actually had like a goal, if we can double that, and half of that second half is through insurance. The problem is we will make more money because you charge the insurance more. So our price will double if we charge the insurance, but it takes a lot of paperwork and you have to do a lot of, it's a complicated process, and when we start looking at it and how much regulations, how much testing, we kind of like...
We just have more work to do to get there with phase 1.
So how much does this standard crutches
from $30 to $40
with the insurance, without the insurance?
That's just on Amazon and stuff. And with the insurance, they give it to you for free at the hospital, but depending on the manufacturing, they charge, some of them charge $200, $250.
What if it's out of network? I got a couple more questions. I'll try to make them as simple as possible. So, we kind of talked, where I was going with your FEA on that, which again, it was very good, by the way. What kind of failures did you guys get in the beginning, and then what did you guys use from that to kind of improve your design?
For our concepts?
Yeah, from the very get-go. So, like your early concepts, right? I'm sure you had statistical failures, and you're probably like, oh man, this is going to crack, or this material sucks, whatever. What were some of your early failures, and how did you take that and apply it to this final design?
From our first design, we were going to go with a compression canister that was filled with nitrogen gas.
Okay.
The issue we had with it was that, as you can see with this one, that it had a pushback. That one had even more pushback once we ran, I guess, just a couple of tests on it.
Okay.
So, but the biggest issue we had was on our second design concept.
Mm-hmm.
It was that push button mechanism that I had explained earlier.
The pin.
Like the pin. The issue with that one was we were trying to get that ball running inside that baffle. It has to cross at minimum of 4 inches in height.
Okay.
Now, the way the baffle, the pathway is drawn out, it actually has to travel 6 inches, because it goes up, down, then high, then low, and it locks in these 2 separate spots. So it has to travel basically 6 inches in something that is 19.2 millimeters, which is just under an inch.
Mm-hmm.
So to create that pathway and getting this ball to go up 6 inches in something so small, it was very difficult to do. We tried to 3D print it, and none of the 3D printers printed it out correctly. We did it, I think, twice or 3 times, and it wasn't able to print out properly.
Plus, with the minimal diameter that we did try to use with the crutch that we have now, when the ball was going up with the compression spring chosen, there was a high loading on the maximum portion, and so just with the smaller diameter that we did the FE and all stuff, so it just wasn't viable for the small diameter.
We didn't want to compromise getting those 4 inches of height with something that would be a little bit less inclined for that ball to travel to that pathway. So we just had to move on from that.
For new design, I think the major issues we got when we calculated the spring by itself, we were experiencing, our calculation was giving us that you can see a little bit buckling of the spring. So we end up like doing research and stuff and say as long as you brace it, the spring would not fail. So it wasn't failing, but it was because the flexion is so high. It's a 10-inch spring, and we have bringing it down to 4 inches.
Yeah, that's a lot of trouble.
It was like it was performing like it wanted to buckle left or right. So what we did, we got it like close to the diameter of the cylinder, so it has like a bracing mechanism. In the shipless book say that you need to have bracing for able to work. The 3D printed pieces, it was good to end up doing a FEA analysis, but when we first did our pieces, they were more aesthetically pleasing, and it had a lot of nice sharp edges and stuff. But when we took it to the CNC shop, when we did the FEA analysis, it started showing a lot of failure closer to the bolts and the fasteners. So by adding more material and filament to it, and we ran the FEA analysis again, it shows minor deflection or minor shear or anything on.
Okay, so back to the CNC thing. I saw a drawing on here. I don't know if we're able to go back to that. No, keep going to the block, I think. There you go. What drove your tolerances? What's your tolerance range? So it says, for example, the diameter is 22, right? You have to have a tolerance on that. And why 22? We
want it because the crutch is going to be outside, mostly outdoors. We wanted a snide is not fit, so no dirt get on it and stuff like that, because we got a spring with grease and stuff like that. So we wanted like a tight fit. So we pretty much designed every piece, and we took measurements of the original crutch, and we kind of back engineers like what we need to do to make it not rotate and stuff. So
you're saying you wanted to snug fit, like any idea what your tolerances might be?
Yeah, plus or minus 5 millimeters.
Plus or minus 5 millimeters?
Yes.
Okay. Okay. I think, last question, I promise. What's your typical turnaround time on this? Like, let's say you get an outstanding order of a design of these things. How long is it going to take you to make these? What's your scope?
We're going to put the Gantt chart here. Sorry about that. But it was hard because like we explained at the beginning, it was hard for us to design it. It looked like a simple static design, but nobody came up with this idea at first, and we had a lot of issues trying to figure out what would work and what would be safe and acceptable. So it took us a while to come up with a good design that will actually work. But what we figured out after we finalized our drawings, we did all calculations, and we did everything we needed to do, it took us real easy. Like we got quotes for the CNC shops, and he said we do 1,000 pieces, 1,000 pairs. The price will, because it costs us like $100 for the little supports. But he say if you order 1,000, he will drop the price to like $35.
I would hope so.
And then, and then the same thing with the. As of right now, we painted the crutches, spray painted, but we got a quote for powder coat in place.
Right.
Because since we funded ourselves, the powder coating, just to powder coat a pair of crutches was like $80.
Is that a magnetic powder coat, or is it?
A magnetic, yeah,
magnetic,
out of Spring, Texas. And he said if we do 1,000, he would drop the price to like $20 per piece. So we end up seeing the like, as soon we had a good design.
Magnetic and then bake?
Yeah, yes, sir.
Okay.
So as soon we end up finding a good design, like they end up start giving us a better turnaround point. With one crutch, they were giving us like, oh, you got 4 weeks turnaround point. And then when we started like 1,000, they're like, oh, we can get it done in 2 weeks.
So, all right, thank you guys.
That's how it works.
So, this is kind of an out there question, but let's say when I'm falling, let's say I have an accident, I fall and I break my leg, but in that same accident I break my thumb.
You can use the index finger.
What if I break my thumb and my index finger?
That's next semester's English design.
Senior design 3.
Using middle.
Wireless consideration, you know.
Any other questions?
Use your feet. Use your other foot.
Do you have any concerns about like an accidental discharge if they're just using it? It looks like it could be in the spot where they accidentally hit it.
You have to put weight on it in order to engage it.
And,
Okay.
right. Otherwise, even if you just use it,
If you
it
just
won't-
push the lever, it's not gonna.
I got a question, if I can. Can I just see you like walk with like the difference between just regular? I know it's made for stairs, but how does it interact in like everyday use? Have you checked that?
Yeah, it's the same.
Yes.
Same way, so you want to walk with those and I'll walk with these. So, same thing here. And then if you want to...
If you want to try the stairs, you can see how actually improve. Like I know it's hard to see in the video, but when you try going up and down the stairs with the regular crutches and you try or design, you can see the big difference.
It's definitely, I can
It
say,
really
like,
gets in the way.
I've tried it going down the stairs. It's not just because we designed it, but I definitely felt a lot more stable going down up the stairs. I would say it felt comfortable both ways. I mean, more comfortable with this one, but going down the stairs when you really see the difference. I felt a lot more stable being able to put my foot down first, and the crutches not pushing my shoulders up. I was able to have them at a regular height, and then I can just put the crutch down and just continue that. I just felt a lot better, a lot safer.
Did you guys get into any ergonomic like data? Did you have any detriments from ergonomic like evaluation? Because being in that position, it doesn't look comfortable.
It's because we have one height. It's not height adjustable,
Okay.
so it's off for them especially.
Oh, okay. But is that a yes or a no?
It's like a future consideration.
Basically, what we want to do is we want to be able to have something here where you can basically push out the pin
Okay.
and be able to adjust the height of the attachment. That way it'll adjust the height of the crutch. Right now, since we have it all stable, it's built for one height right now.
Okay, understood. Thank you.
Thank you, Ruth.